Okay, let's dive into J.J. Thompson's discovery and his famous plum pudding model. All right, so first, let's talk about plum pudding. Here's an example. I figured I better put a picture up here because you guys, we're from America. We don't have desserts. We call desserts cakes and pies. And so I wanted to talk about plum pudding since most of us aren't familiar with this British dessert. Think of it like a squishy muffin or like bread pudding with raisins scattered throughout. The British call dessert pudding. It's just what they call it. And so it's not like a custard, it's more like a cake or like a muffin. And it had all these, you can see it in the picture, like raisins and nuts and all things kind of scattered throughout. So Thompson imagined an atom as a ball of positive pudding or cake with these tiny negative plums, which were the electrons that were stuck inside of it, like raisins in the dessert. Okay, so I think I need to explain how Thomson came to understand that there's a subatomic particle called an electron. Okay, remember, up until now, we've got Dalton who says atoms are just solid spheres. There's nothing in them. There's nothing that you can. There's nothing that you can divide an atom into anything else. It is what it is. And so Thomson, when he discovered that, wait a second, there's electrons here. That was a huge advance in the atomic theory, and he did this with a device called a cathode ray experiment. Now, before I go on and talk to you about this, I'm going to go back a second. Look at the time. Okay, we go from 1803, and nothing really huge happens until almost 100 years later. And something kind of interesting I want you to know. John Dalton was a teacher, and J.J. Thompson was his student. So Thompson was pretty young when he was working for Dalton in his lab. And then when Thompson kind of grew up and sort of branched out on his own, and he was making his own discoveries, almost 100 years later, this is what happens. So he used this device called a cathode ray tube. And basically, it's a sealed glass tube with a little bit of gas inside. And there are two metal plates on either end. Okay. So this metal plate here and here, I want you to notice that there is a positive charge on the bottom plate and a negative charge on the top plate. And when he ran his electricity, he ran that electricity through it, this beam of light appeared. And then he noticed that the beam could be bent by magnets or charged plates, which means you guys understand this now, because when we were doing our magnets, our games with our magnets, you understand how charged particles behave. Like charges repel and opposite charges attract. So take a look at that beam of light that's going through. It's the blue line. If the top plate is negative and the bottom plate is positive, what charge does that beam of light carry? It's repelled by the negative charge, and it's pulled by the positive charge. So it has to be negatively charged. And so in order for it to have this negative charge, Thompson was like, wait a second, there are these particles that are negatively charged in that ray of light. It's an atom, which blows my mind that there are, like, right? So that is an electron. It's amazing. Okay, I'm going to show you a video that explains this experiment in a way that it's really easy to follow. And the reason why I want to show you the video is because I can describe this all day long, but it's actually pretty cool to see. So this teacher recreated it in his classroom. And I'm going to play the sound. I hope that it matches, the video matches with the sound, but it may be just a little bit behind. Bear with it. Here we go.
Okay, this is a cathode ray tube. What it essentially is, it's a vacuum chamber. There are no gases inside this glass tube. The only thing we have are two electrodes, one's called the cathode, the other's called the anode, and a fluorescent screen in the background. It's coated with some type of fluorescent material. When I turn the power supply on, we'll see a beam that causes that fluorescent screen to glow. Looks like a nice straight line, doesn't it? We call that a cathode ray because it emanates or begins at the cathode and shoots across over to the anode. J.J. Thompson was working with cathode rays. We really didn't understand what they were. I mean, we have electricity going in one side and coming out the other, but there's nothing inside to conduct it. It's a vacuum tube. So he decided to apply a magnetic field to this cathode ray, and he found something interesting. We apply one pole of the magnet to this beam and we'll see what it does, and then we'll flip it around and see what the other pole does. This is my favorite part. Can you see what's happening to that beam? What does it appear as though it's happening to it?
It's moving.
It's moving, it's being repelled, isn't it, by the magnet. When we flip the magnet around, and what do you think is going to happen this time? Well, if it's being attracted on one pole, see how it's being attracted there? Let me rotate it so the kids on this side of the room can see it. See how it's being attracted there? And then the other pole, do you see how it's being pushed down? What does that tell me about that beam? It has a what? It has a charge. Let me tell you about the poles of the magnet. The one that pushes it away is the negative pole. So what does that tell you about the charge of those particles? Negatively charged particles. And J.J. Thompson was actually able to do a charge to mass ratio of these particles, and he found that these particles were about 2,000 times lighter than a hydrogen atom. Now at the time that was very profound. What did Dalton say? Are there any particles smaller than an atom? J.J. Thompson just found something 2,000 times smaller than a hydrogen atom. Why is the hydrogen atom and something 2,000 times smaller than it so profound?
Hydrogen.
Because hydrogen is the smallest atom, isn't it? So if we found something 2,000 times smaller, we have found our first subatomic particle. And it's called the electron. That'll work good.
Whoops.
Okay.
Sorry. So he found the electron. I think that is fascinating. Man, can you imagine what it would have been like to be alive during that time and to be a part of all of this where you're discovering? Like, this is stuff we get excited talking about. Mars. We get excited talking about things that we have not yet discovered. Nobody knows anything about, and you're just learning about it for the first time. I also think about brain research because scientists don't truly fully understand the brain. And so if you are a part of this and you're learning about it, gosh, how exciting that must have been. Okay, let's pause for a second. I'm going to let you go ahead and write down these key points. First of all, J.J. Thompson discovered electrons, and he proposed the plum pudding model, and I'll put it up there in a second for you. And basically what he's saying is that Dalton's atomic model was incorrect, that atoms no longer are seen as being indivisible. In other words, it can be divided into even smaller particles, and he called those subatomic particles, and specifically electrons. So one thing that you guys are going to be asked on your test is who discovered the electron. You need to know Thompson did it. Thompson, all day long. Love it. Okay, I'm going to show you the plum pudding model. Okay. Here's a picture, and I'm going to have you literally copy what I have. Okay. It might be easier for you to draw the circle, which is your positively charged matter. Go ahead and color that in, and then draw black dots or circles, and then with white come on top of everything and then do your charges. So understand, if you're looking at this, it looks like a chocolate chip cookie, doesn't it? It's very two-dimensional. And right now we're kind of understanding that it's still spherical, but we're drawing it two-dimensional to make it easy to see. But just like plum pudding is kind of, it's got these black raisins all throughout everything, kind of, and not really in any particular order. This model is actually pretty ordered. Everything is really nice and neat and spaced evenly. And Thompson was like, they're just kind of all over the place. The cake part of the plum pudding model, or the cake part of a plum pudding, he said that would be, if you're using that as a model, the cake is positively charged and the raisins are negatively charged. So there's no one thing that carries a positive charge, but there are subatomic particles called electrons that carry the negative charge. Now we know that's not correct. And the next model that you guys are going to watch a video for on the next time, that will be where it's kind of fascinating, because things are going to start happening really, really quickly. You're going to notice the times when you guys look at your time on your time chart, on your timeline, that the dates are getting closer and closer together, because there's such an advance in technology. People are learning from each other. Like I said, Thompson was Dalton's student, and Rutherford, who we're going to learn about next, he was never Thompson's student, but he did work with Thompson in Dalton's lab, believe it or not. So I mean, they've all been influenced by each other, and they, study each other's work, and they're fascinated by what's going on. And so they all kind of use the same tools and technology. And so it's fascinating time to be a chemist, a physicist, and learning about the atom. All right, that's it. Let me know if you have any questions.